Welcome everyone to your own channel, ADP for Learning. I am your own learning partner cum host, Ashish. So, let's begin our learning journey. Have you ever thought about the wings pattern in pigeons? Today, we will explore and learn about the genetic basis of the wings pattern mystery in pigeons. Before going deep into the topic, utilize a few seconds of yours to like, share, and subscribe to your own channel ADP for Learning. Now coming back to the topic of the wings pattern in pigeons. Pigeons can have 4 different wing patterns: bar, barless, check, or T-check. Bar is considered wild type because it was the pattern in the wild ancestor to domestic pigeons. The other patterns are due to natural genetic variations, which were selected and propagated by breeders. Barless is the rarest wing pattern, available in just a small number of breeds. The pigeons that have been shown in the picture are all colored blue, but each has a different wing pattern. So, the question may come in your mind, what is the genetic basic behind the wings pattern in pigeons? The wing pattern is controlled by a single gene, which comes in 4 different versions, or alleles. Pigeons inherit 2 copies of the pattern gene, one from each parent. The 2 alleles together make up a bird's genotype. What we see, also called the phenotype, reflects the dominant most allele in the genotype. T-check is the most dominant, followed by check bar, and finally barless, which is recessive to all the others. While this dominance pattern generally holds up, sometimes the less dominant allele does have a small effect on the phenotype. For instance, a bird with 1 T-check allele and 1 bar allele may have flecks of lighter feathers rather than a solid black wing. The pattern is a great example that shows the relative aspect of dominance and recessiveness. An allele is never simply dominant or recessive. It is always dominant to or recessive to another. The term wild type implies nothing about an allele's dominance. It simply refers to the allele that was most commonly found in the wild ancestor. Depending on the gene, the wild type allele can be dominant or recessive to other alleles. In fact, bar, the wild type allele for wing pattern, is dominant to barless and recessive to T-check and check. Also, the gene for the pattern is on the same chromosome as the gene for spread. The 2 genes are close enough together to be genetically linked. They are separated by a recombination event less than 50% of the time. That is, unlinked genes are inherited separately exactly 50% of the time. As shown in the figure, linked genes are close to one another on the same chromosome. They are inherited together more than 50% of the time. Thank you for joining with me for the amazing journey of learning. In the future, we will again meet with other new, innovative topics. Meanwhile, don't forget to like, share, subscribe, and comment.